Last week, we received the robotic arms from Interbotics via express delivery from the United States. We wrote several Python programs to control the robotic arm using the Interbotics APIs. We conducted double verification through simulation and actual operation. The achievement of last week was to control the robotic arm using the Interbotics APIs. In fact, the whole process had no direct relationship with the Stanford Aloha robot project. The task of this week is to assemble the 4 robotic arms into 2 groups according to Stanford Aloha robot architecture. In each group, one robotic arm is manually controlled and the other robotic arm automatically imitates the exact same movements. The system architecture of Stanford Aloha specifically includes the following components. 1. Our OS/2 package. Since the operating system used by Stanford Aloha is Ubuntu 20.04, while the current popular Ubuntu version is Ubuntu 22.04, and the ROS used by Stanford Aloha is ROS 1 Noetic, while the current popular ROS version is ROS 2 Humble, we decided to use Ubuntu 22.04 and ROS 2 Humble to recreate the package. Recreating the package means we have to rewrite package.xml and cmakelist.txt. These 2 files are stored on GitHub, open source, free, and can be used for commercial purposes. 2. Launch file. Due to the same issues with Ubuntu and ROS versions, we also had to rewrite the launch file. Stanford Aloha uses the XML format to write the launch file, while the new version of Interbotics' launch files are written using Python programs. Therefore, we also rewrote the launch file using a Python program. The launch Python program is also stored on GitHub, open source, free, and can be used for commercial purposes. Three. RViz simulation. The Stanford Aloha project team did not provide RViz simulation. In order to facilitate system debugging, we imitated the Interbotics Puppet example and created a new RViz configuration for the Stanford Aloha system. It is also stored on GitHub, open source, free, and can be used for commercial purposes. After debugging, Stanford Aloha was able to work normally under the RViz simulation system. We used a Python program to control 2 small robotic arms, Interbotics WX250S, and then the system automatically let the 2 large robotic arms, Interbotics VX300S, imitate them step by step. Physical implementation. Since it works normally in the RViz simulation system, then it should also work normally with the physical robotic arm, right? However, in fact, the 2 large arms did not imitate the small arms exactly as expected. We suspected that there was a problem with the servos of the robotic arm, so we used the monitoring tool provided by the servo manufacturer, Dynamixel Wizard, to monitor each servo. Through monitoring, we found that the root cause of the fault was that the movement of the elbow servo on the large arm could not be synchronized with the corresponding elbow servo on the small arm. It could be a setting issue with the servos on the Interbotics robotic arm, due to the manufacturer's negligence. Fortunately, we found a partner in Beijing, bjrobot.com, who successfully copied the Stanford Aloha system. They manually controlled 2 small arms, and then the system automatically let the 2 large arms imitate the movements of the 2 small arms step by step. We will go to bjrobot.com for help next week.